So you guys, welcome back. I hope your graphing is improving a little bit. They're going to do one more example. If you're like, Miss Chang, I get it, then you can actually start the homework if you'd like, okay? But for now, I'll do another one. It says right here, example 54, graph two full periods, y equals 3 cosine 6x plus pi. This indicates that there was a phase shift, and let's also write the equation again. Y equals a cosine bx minus c plus d. Or y equals a cosine b x minus c over b plus d, okay? Whatever you like. I actually like, I told you, like this way. So let's rewrite this equation into this method. It tells me the left and right shifts, right? So y equals 3 cosine 6 x plus pi over 6 is the way I like to see this graph. I could already tell you that the max is going to occur at negative pi over 6 because this gives me 0 there. Okay, you'll see what I mean. Let's do the first step. Always keep it consistent. First step, a peanut butter plus the midline. A peanut butter. Okay, your amplitude is 3. Your b is right here, right? Your b is now pulled out, so it's 6. Easy to see. And your period is 2 pi over b, but your b is 6, so it's going to be pi over 3. And your midline, was there a vertical shift? Nope, so it's going to be equal to 0. That's your midline. All right, this should become automatic to you after we do it a few times. Let's go to step 2. Second step. Second step is your start and end, right? Your start and end, right? So let's do this. Okay, so there's two ways, you guys. You can do 0 is less than or equal to bx minus c is less than or equal to 2 pi, which is the usual cosine period. Or you can do it 0 is less than or equal to x minus c over b is less than or equal to your period. Your period, okay? I like doing it this way, but either way you do it, you guys so you could remember all these because this is also your shift already. So you see how your period and this is your period shift, and it's going to tell you where to start and where your first cycle ends. That's what this is doing. So whatever you like. So that's what we've been doing too here. I like using this method better. But either way you solve it, when you solve for x in the middle, you're going to get the same values, okay? So I'm going to use this method. You can try this one if you'd like. So ours is 0 is less than or equal to, this guy is going to be x plus 6, right? X plus pi over 6, and our period is actually pi over 3. And when you solve that, you guys, for x, you subtract pi over 6, pi over 6, pi over 6 here, you get negative pi over 6 is less than or equal to, x is less than or equal to pi over 6. Okay, and think about that, okay? Negative pi over 6 to pi over 6, because this is 2 pi over 6 minus pi over 6, right? When you simplify, okay? And that's going to be your start and end. And then I'm going to put out another sheet here, so make sure you digest that a little bit. All right, now what's our third? What's our third step? Interval. Our third step was interval, right? Interval is always going to be interval, okay? What's our interval? Interval is always going to be 2 pi, your period over 4. What's your period? Pi over 3. And what's 4? It's going to tell us the 4 other critical points, which means you get pi over 12. Looks kind of ugly, but don't be scared. That means, okay, what was our start? Our start was negative pi over 6, right? And what was our end? Pi over 6. That was our start, right? And this was our end. That means every point between that, we're gonna add. We're gonna add pi over 2, pi over 2, and pi over 12, and pi over 12. And you know what, you guys? It's miraculously, they always work out that you get pi over 12 like this. It always ends up that it's gonna be add up to pi over 6. Let's try, okay? Pi over 12. So you guys, I'm gonna actually write this guy as negative 2 pi over 12, because then it's easier for us to add. So we get. So this guy, negative 2 pi over 12 plus pi over 12 is going to give us negative pi over 12. Next one, we add a pi over 12, we get 0. Next one, we add pi over 2, we get pi over 12. And you guys, what about next one when we add pi over 12? Doesn't it give us 2 pi over 12, which is pi over 6? Ta-da! It always works out. These are our 5 critical points. This guy, this guy, this guy, this guy, and this guy. And you guys, all we've done right here is we've just simplified the fractions, okay? All right, go ask each other what this means, okay? Please, what this means, okay? And remember, these are not multiplying. This is just simplified version of that. All right, let's graph now. Let's graph. Let's do this. Y equals 0 because there was no vertical shift, and our equation is y equals let's write our full equation, which was 3 cosine 6x plus pi over 6. Okay, look, it moved to the left, negative pi over 6, huh? All right, so it says our first one is negative pi over 6, right? Negative pi over 6, negative pi over 6, negative pi over 12, and our next point is 0, pi over 12, pi over 6. Okay, I'm going to write this y equals 0 smaller, but I'm going to write it here. Okay, all right. Now, we have this. Let's mark our critical points. But you guys, isn't this a positive amplitude? And it's a cosine, so we know we start at our max, right? And then we go back to our mid, and then we go to our min, and then we go to our mid, and then we go back to our max. So we know, oh, amplitude is what? 3, right? So 3, 1, 2, 3. So we're going to start here. Starts at the max, it goes back to 0, it goes to the min, it goes to the 0, and it goes to the max. So it should look like this. And you guys, I'm sorry, this is pi over 12, this is negative pi over 12, and this is 0, our critical points. Okay? And of course, it wants us to do 2 periods. So you can keep going, you guys. How about here? Let's keep going, okay? So this guy is 2 pi over 12, right, guys? Keep adding pi over 12. So isn't this really 3 pi over 12? Isn't this 4 pi over 12? Isn't this 5 pi over 12? Isn't this 6 pi over 12? You can actually simplify these fractions, but I like to do it this way because it's easier for you guys to see the points better. So here, I go back to min, I go to the min, I go to the 0, and I go back to max. So here's my rest of my, okay, and then you have to indicate, and you guys, here, we're going to ask you that you guys indicate that the arrow is here and that this also continues this way. Okay, you don't have to label all of them. You just have to label the 5 critical points. Make sure you label these 5 critical points here. Okay, so this guy is what? Negative pi over 6, and this is 1, 2, 3. Okay, this guy is negative pi over 12, 0. This guy here is 0, negative 3. This guy here is pi over 12 and 0. This guy here is pi over 6, 3. Okay, 5 critical points have to be labeled, and we've done 2 periods. Boom! Alright, you're sick of graphing. I get it. I get it. So now we're going to actually have you identify the graph of the given graph, okay? So I'm always going to give you guys the format that I want the answer in. That means you need to find the A, the amplitude, and if there was any, a phase shift. You'll see why I need to indicate that for you, all right? So let's look at this graph. Okay, you're right. It could be a sine graph if you start here, or it could be a cosine graph if you start here. But you can see that there was a phase shift vertical up and down, huh? I mean, it's not a phase shift, a vertical shift up and down, huh? So let's actually identify that first, because I want it to be a cosine graph. That means it either has to start from the max or the min, okay? All right, so let's actually look. You guys, look at the min. Isn't the min 0? And what's the max? The max is 8, okay? That means we should actually figure out what's the midline, right? So let's do the midline first. I feel like that makes the sense most, okay? So let's find the midline. Isn't the midline D equals, right? Like y equals D, right? Where is that? Isn't it actually just max plus your min over 2? So D equals 4. Let's go up. 0, 1, 2, 3, 4. And let's actually go ahead and draw that line. And now it's pretty clear that this is the midline. And now we can actually calculate the amplitude. We can count if you want to. But let's do the first step here formally. Amplitude, which is A, which is max minus min over 2. We don't need these corny equations though. We know that amplitude is the distance from 4 to our max. So 4 to max, 4 to 4 is going to be, you're right, it's 4. Let's make sure though. From 4 to 0, what's that distance? It's 4, 2. So our amplitude is 4. Let's go to 2. So we already have our D. Okay, we have our D, which is 4. And our amplitude is also 4. And let's do our period now. Now, isn't period 2 pi over B? Okay, but what's our B? Our B is 1, huh? So really it's 2 pi over 1, isn't it? So, right? Is that right? Okay, because there was no phase shift, right? So you guys, our period is done. It's 2 pi, okay? But now it's 2 pi, I get that. But let's analyze this graph a little bit. Now this is 12.56, all the way from here, okay? So the fourth tick was 12.56. And now we should recognize that this is about 4 pi. That means each of these guys must be pi, huh? Negative pi, negative 2 pi, negative 3 pi, negative 4 pi. Okay, we should recognize that, okay? Now what we're going to do is this. Okay, so we know that there is no phase shift. That means it started at 0. Well, if it's a cosine graph, why did it start? Oh, it started at the minimum. What does that tell us about our A? It must be negative 4. Cosine, our B is 1, so it's going to be x, right? Plus 4, our D is 4. Okay? You guys, if period equals 2 pi over B, what's B? B is also equal to period, 2 pi over period. And that's how we should have done it, actually. Look, don't we find a period from pi to pi? What's pi to pi? That's 2 pi, isn't it? That's why we knew this guy had a period of 2 pi. How about from min to min? How did you get from 2 pi to 0? You travel 2 pi distance. That's how you calculate period, okay? So here's that. Let's try number 69 now. Find a, b, c to write a function f of x equals a sine bx minus c to represent this function. Okay, a couple things to notice here. You know 6.28 is about 2 pi, okay? Just keep that in mind, all right? And this is a sine graph. That means we start at the 0 or the mid, okay? All right, let's also do amplitude first. So A, first step is always the amplitude. Is an amplitude just 1? Because there was no phase shift. I'm giving you this, right? There's no D here that I added, so amplitude is 1. Second, let's do period. And period is 2 pi. Let's check. Okay, period is 2 pi. Are you sure? Let's check, okay? Period is 2 pi. Let's check. So period is 2 pi. Let's check. So let's go from math. We could go from, I don't know, 0 to 0. And I know you're going to complain to me that this is hard to say, but 1, 2, 3, 4 is 2 pi, right? That means this guy must be pi. That means this guy must be pi over 2. This guy must be 3 pi over 2. And this guy is 4 pi, negative pi over 2. So make that kind of assumption on your own, okay? All right. But you know, I mean, there's so much you can do. What if I want to go from here to the next time it hits that, okay? Or anywhere. Like, how about from negative pi? How about negative pi? And now where do I come across that again? Right? Where do I come across that again? It's about right here somewhere. So like this. That completes one cycle. Because it's coming down, not here because it's the same position, but you remember how it always has 2 values that it reaches it at, but it's here. So what is that? It went from negative pi to pi, so that's how we know our period is 2 pi. We could even go from max to max, but it's harder to tell here because there's no specific coordinate here. So that's 2 pi over b, right? B, okay? Our period is 2 pi, but b. So we need to calculate b. b is 2 pi over our period. What's our period? 2 pi. So our b must be 1. Okay? Our b is equal to 1. Let's go to the third step. bx minus c. bx minus c equals 0. Okay? Well, what's our b? b is 1. Okay? b is 1. What's our c? Which will indicate our phase shift, right? Well, let's look. This is a sine graph, right? So didn't it shift half of pi over 2? Or even to the left, isn't it half of pi over 2 that it actually started? Because our 0, right? Where are we starting? It's about like right here, right? Our 0 is here. So it moved halfway between 0 and pi over 2. So we can assume that our x minus c, I'm trying to figure out the easiest way to explain this. This could also be written as this, right, guys? bx minus c over b is equal to 0. Our b is 1, so it's going to be x minus c over b is equal to 0. X equals c over b, right? Okay. But what's our b? Our b is 1. So wait a second. What's the easiest way? What's the easiest way to explain this? bx minus c is equal to 0. So b is 1, x minus c over b. Okay, we could do it this way. But you guys, wasn't there a phase shift of pi over 4? That's the way to think about it. You guys, doesn't this indicate the phase shift? So c over b has to equal pi over 4 because there's a phase shift of right pi over 4. Of course, you and I could have a different equation actually if you move the other way. But we'll talk about that when I return. Okay? And you know that b is 1, so c over 1 is pi over 4. So our c is pi over 4. Okay, so here's our grand equation. Y is equal to A, which was 1, and you know that it started from the minimum and it went up first. So we know it's going to be positive 1 sine x bx, which is 1, minus, I'll write the 1 here for now, and it's pi over 4, which was our phase shift. All right, good luck. This is a little bit tricky, but I think you're going to be okay, all right? Practice. Bye.